Okay, this is about ethane dioic acid, which is a dicarboxylic acid. Draw the skeletal formula of ethane dioic acid. Okay, so I'm going to start with the displayed formula. Well, not quite displayed because I haven't displayed the OHs, but I'm doing this in order to kind of work out my skeletal formula. So with my skeletal formula, I'm basically going to have, so if I start, that's 1 and that is 2 there. Let me put those numbers on. So this is number 1, this is number 2 over here. So on carbon number 1, I have a carbonyl group and an OH. And on carbon number 2, I have a carbonyl group and an OH as well. And again, whenever you do anything like this, if there's any working out, make sure that you cross out the answer that you do not want marking. Ethane dioic acid is formed by the oxidation of ethane 1,2-diol. So this is the alcohol to a carboxylic acid, which means the reagents acidified potassium dichromate. So if you don't know the formula, write the name. And if you remember, primary alcohols can be oxidized to an aldehyde, which requires distillation, which can then be oxidized further to the carboxylic acid. And if you're going all the way to the end, you need reflux. Okay. Part C. Ethane dioic acid reacts with an excess of sodium hydroxide. So you're told that this is in excess. To form sodium ethane dioate, a student mixes 10 centimetres cubed of 0.4 moles decimeter cubed of ethane dioic acid with 50 centimetres cubed of 0.2 moles per decimeter cubed of sodium hydroxide. Show that the sodium hydroxide is in excess. That's the first thing I need to do. And then B, calculate the mass in milligrams of ethane dioate that can be formed in this reaction. I do already have a reminder down here that it needs to be in milligrams. So I'm going to start with part A, show that the sodium hydroxide is in excess. So starting with the ethane dioic acid, so number of moles is concentration times volume. So that's this one here, which is 0.4 times 10 times 10 to the minus 3, which is equal to 0.004 moles. Okay, so now I'm going to have a look at the sodium hydroxide. So the number of moles of sodium hydroxide is concentration times volume. So concentration is 0.2 times 50, that's the volume, times 10 to the minus 3, and that equals 0.01. So that's my moles of sodium hydroxide. This is my moles of ethane dioic acid. So, and you can go either way here. We've got to take into consideration here the ratio, because for every one of those, you need twice as much of this. Okay, just to kind of go this way then, so for every one of these, for every 0.004 moles of this, I require 0.008. Okay, so times 2, so requires 0.008 moles, and 0.01 is greater. Therefore, in excess. You can work it back the other way. I'm not going to write it down, but I'll talk it through. So to use 0.01 of sodium hydroxide, so if I halve it going the other way, I need 0.05 moles of the ethane dioic acid, and I haven't got enough. So again, it's all telling me that the sodium hydroxide is in excess. So let's go on to the mass. So calculating the mass. So if this is in excess, this is my limiting reagent. So this is the one that I'm going to use here. So if I have 0.004 moles of ethane dioic acid, now we're looking at a 1-to-1 ratio here. So I'll make 0.004 moles of sodium carbonate, sodium dichromate, sodium ethane dioate. Sorry, I'll get there in the end. So the mass of this is going to be equal to the number of moles multiplied by the MR, and the MR of this is 134. So that gives me a mass of 0.536 grams, but the question wants it in milligrams, so that will be 536 milligrams. So here's where the marks are. There's 1 mark for calculating that. There's 1 mark for calculating this. There's a 1 mark for showing or explaining why 1 is in excess. 1 mark for using the ratio to get the moles of this, and then 1 mark for the mass in milligrams.